Today we are going to continue discussing graphing, and we're going to use page 7 in your packet. This is the page that we skipped yesterday. The goal of today's lesson is to see if we can apply some things about quadratic functions to an application problem, a real-life model. And I also want to show you how you can use the calculator to check the max or the min of the function instead of simply relying on algebra. So we'll still rely on the algebra, but can you check a max or min using the functions of the calculator? So again, turn to page 7 in your notes and take out your calculator. So the first thing that we're going to do is we're going to go to the y equals button in your calculator, and you're going to plug in the equation. And the equation that we're using is the one that's given here, 3x squared minus 18x plus 20. We will then hit the graph button. We're going to use the second trace button, which we've used before when we were looking at absolute value. And you're either going to use number 3 or number 4 underneath that. So whether we're finding a min or a max, it depends on which one you're going to use. And again, we'll go through this in a minute. I'll show you what buttons to press in a calculator in a minute. After you do that, the calculator is going to ask you to do a few things, and we'll work through that step by step. So the first thing, let's look at this equation. Y equals 3x squared minus 18x plus 20. We need to decide if this is a maximum or a minimum. To do that, we have to focus on the a value. In this case, a is 3, which is greater than 0. That gives us a parabola that is a happy parabola. It opens up. And the vertex is a minimum value. Algebraically, we can find this minimum value by using x equals negative b divided by 2a. But I would like you to pull out your calculator and see if we can use the calculator to help us. So if you go to your calculator, hit your y equals button, and type in the equation that is given to you. So we're typing in 3x squared. Remember, there is an x squared button. And then we have minus 18x, and then plus 20. You're going to hit the graph button, which is at the very top right, and you should see your graph shown. So we have a parabola drawn in this graph. So now we want to find the minimum of that parabola. We're going to hit second trace. Trace is right next to the graph button. Since we said this was a minimum graph, we're going to use number 3. So hit 3. Underneath on the bottom of your calculator screen, it says left bound. The little blinking cursor needs to be on the left side of the minimum. So you have to use the right arrow to get it to arrow down, because right now it's probably high on your parabola. So if you use the arrow button, you want that blinking cursor to be somewhere to the left of the minimum of the graph. So right now my blinking cursor is on the left side of the minimum. Once you get it to the left, hit the enter button. And you should see a little arrow appear, because right now the calculator is trapping where the minimum is between two values. Now it says right bound. Right bound just means that I need that little blinking cursor to be on the right side of the minimum value. So once you get it to the right side, you're going to again hit enter. You should now have two triangles that are pointing towards each other. In between those two triangles should be the minimum value. When it says guess, don't do anything besides press enter. So you're not moving anything, you're just pressing the enter button. And now the calculator is showing us that the minimum is at 2.9999999, which is actually the value of 3 and negative 7. And yours might actually say 3. It just kind of depends on what it's doing with the calculator. So going back to the notes, we know the vertex happens at 3, negative 7, but the minimum value is just the y. So the minimum value is negative 7. So the next question that we're going to look at today is how to take something going on, real life model, and try and apply that to come up with an equation that would be a quadratic function. So this question is talking about a go-kart track. That go-kart track has 380 racers a week and charges each racer $35 to race. The owner estimates that there will be 20 more racers for each week for every dollar that he reduces the price per racer. How can the owner of the go-kart track maximize the weekly revenue? So our goal is to come up with the most amount of money that he can earn. So I'm going to say that is our R. We need to think about how he can do that. And that's where the $1 reduction comes in. So for every $1 that we reduce our price, he's going to gain 20 extra racers. But we don't know how much he should reduce his price by. Should it be $1, $3, $5? What should that reduction be? So that's why our variable, the x, is going to represent the price reduction. That's what we want to figure out. How much should he reduce his price by? So if I want to decide what his revenue is, or to calculate how much money he's making, the way we would calculate how much money he's making is by taking the cost and multiplying it by the number of racers. So to get a total revenue, we would have the cost for each racer multiplied by the number of racers that he has. Well, our current cost per racer is 35 bucks. That's what he's currently charging every racer in the race. But we want to know what happens if he would reduce the price by $1 or $2 or $3 or $4. So we want to know what happens if we reduce that price by a certain amount. So to that cost, if I'm reducing something, I'm going to subtract an amount from that cost. But we don't know what to subtract, so we're just going to subtract the x. Because it's $1 for every reduction. That's a quantity that we're going to group together in parentheses. So my cost was 35 bucks, but what happens if I reduce it by $1 every time? And every time I make that reduction, I might gain more racers. We're going to think about the racers in the same way. So the total of number of racers he has is 380. But he estimates that he will get 20 more racers if he reduces the cost by $1 every time. So 20 more racers means I would have an increase of 20 racers every time I reduce the cost. And again, I don't know what the reduction is, so that's why we just put an X there. So just going through what we have up here. Our revenue is equal to the cost, which is 35 bucks. But what happens if I reduce it $1 every time? So that's why I have a subtraction sign. I'm multiplying that by the number of racers. Well, we have 380 racers, but I could get 20 more racers, which is why I'm adding it, every time I have a price reduction. Remember, the X represents the amount that we're reducing our price. So now we have this formula. In order to find the most amount, or the maximum value, we have to think about finding the vertex. Well, I can't get a vertex until I have something that would be in standard form. So we're going to first FOIL this to get it into standard form. So foiling, your favorite thing to do. 35 times 380 is 13,300. And then we have 35 times 20x. And then we have negative 1 times 380. And then the last one is negative 1 times 20x. Negative 1x times 20x, so that would be negative 20x squared. So we FOILed that. That gives us 13,300. 700 minus 380 is a positive 320x. And then we have negative 20x squared. So if you want to write that so that it's in standard form, we would have 20x squared negative plus 320x plus 13,300. So anytime you want to find a minimum or a maximum, you need to find the vertex of the equation. This is in standard form, so our vertex is negative b divided by 2a. So here's the b and there's the a. So we're taking 320, it's negative, divided by 2 times negative 20, which is negative 320 divided by negative 40. So the x, or the price reduction that we should reduce our cost by, would be 8. But our goal is to figure out what the maximum revenue would be. So the 8 is the price reduction. But how much money would we be earning, extra money would we be earning, if we reduce the price by $8? To find that, you would take the 8 that you just calculated and plug it back into our equation. So negative 20 times 8 squared plus 320 times 8, and then plus 13,300. To calculate that number, you can plug it in your calculator. So if we have a price reduction of $8 for every person that races, our maximum revenue with that price reduction would be $14,580. So that is the most amount of money that he can make with the price reduction of $8. So what I would like you to do is to turn in your book to page 239, like it asks you to do at the bottom of your notes, and complete numbers 7 and 8. Once you have those two problems completed, and you can complete them with a partner, your homework is partially in the book and it's partially a worksheet. The worksheet will be distributed to you along with graph paper. Graph paper will also be distributed to you. The worksheet reviews the 3 types of graphing that we have done. So there's a few problems on standard form, there's a few problems on vertex, and then also on intercept form. The problems in the book are word problems, and I believe there are 5 of those. So the word problems are very similar to the word problem that we just went over, and also very similar to number 8 on page 239 of your book. The answers to your homework are posted on Google Classroom, and they're also sent to you through Remind. So the Remind app, you should have had solutions sent to you. It's a whole sheet of all of the problems on the worksheet, the graphing worksheet, and also the 5 problems in the book. So the expectation is that if you work with a partner, you're working for the rest of the period on your homework. On Monday, we will talk about any questions that you have from the book homework from section 4.2, and I will come around and check it to make sure that you have it complete. We'll also talk about any questions that you have on the worksheet and the book problems from today's assignment. So Monday we'll go over review of everything that we've talked about with graphing parabolas. Tuesday, you have a quiz on graphing parabolas. So again, Monday, we will answer questions that you have on graphing parabolas. We'll go over anything that you're concerned about. And then Tuesday, you will have a quiz. So worksheet is being passed out to you right now. Please turn